The next presentation is somewhat different, but very interesting indeed. It deals with a development of a green biodegradable composite used of date palm residues and polylactic binder, very special binder. And we are looking forward to your presentation. Please, you have the floor. Noran Mousa1. Thank you.
Thank you very much. Thank you. How to use this one? Pointer?
Yeah.
Oh, okay, okay. Hello, good afternoon everyone. I am Noran Mousa1. I am doing my PhD in chemical engineering at UAE University under the supervision of Professor Basim and Professor Ali Al-Marzuqi. Today I am going to present phase 2 from my master's study, which was the optimization of my green composite, our green composite based on polylactic acid mixed with date palm waste for biodegradable cutlery application. First of all, let me start with the problem statement. Actually, as we know, petroleum-based plastic problems are huge, and everyone are using the petroleum-based products everywhere in all the applications. And we know that they can't be decomposed, and they stay for thousands of years without any degradation. They are the main cause of air, water, and soil pollution, and diseases like cancer. So we need to get rid of them and create our biodegradable plastics. Another problem that we faced in UAE is that the UAE is producing 500,000 tons of date palm waste every year. Those actually are disposed of in landfills or burnt in farms, and as we can see, they are causing environmental pollution and global warming. So, hence, date palm waste can be used to reinforce polylactic acid in cutlery application and other single-use plastic applications. The process started with date palm waste collection. So, the objectives is to create a new composite based on polylactic acid and reinforced with date palm waste, and characterize these fabricated composites and investigate the effect of different parameters such as the melting temperature, melting mixing times, additive types and amount, and their effects on the physiochemical and mechanical testing. The materials, as I mentioned, is polylactic acid, which can be produced by the fermentation of agricultural crops such as corn, sweet potato, and now also my colleague Sabeera and the team is also working from the date fruit waste that after producing the syrup to produce also polylactic acid. So everything will be created from waste. Initially, in phase 1, we tested 3 different composition of date palm waste, which are 30 and 40 and 50%. And we found that based on several testing and characterization that we need to go below 30 to ensure the best product performance that can be comparable to the products available in the market. So in this research, I will gonna explain some of our characterization related to the 3 optimized formulas, and as we can see, the date palm waste was varied from 20% to 27%, and we used the polyethylene wax, zinc stearate, antioxidant, and stearic acid for this optimization. The methodology started with the size reduction of the date palm waste. We used the waste from the fronts, from the rachis, and then we grind it and sieve it. Then melt mixing in using extruder for the polylactic acid and the date palm waste, and we also add the additives. And we have the injection molding for the tensile testing and to create our biodegradable cutleries using the specific needed mold. Moving to the results and discussion, As we can see, we started with the particle size distribution test, and we can end up that 61% after grinding is less than 90 microns, and we have only 1.8% between 250 and 425 microns. The density and the bulk density and moisture content were also tested, and we found it is acceptable and compared with other fibers available, and the moisture content is relatively low, which is good. We also did melt flow index to ensure that our product can be, the flowability of our product can fit the machinery available in the factories, and the product will be, the flowability will be accepted. So all the three optimized formulas are below 30 grams per 10 minutes, so it is acceptable. Moving to the SEM, let us dig deep and go deeply and see the composite using scanning electron microscope. As we know, the PLA, the polylactic acid, is a continuous phase, and the fibers, date palm waste, is the fibers like aggregates of entities that have nanofibers on the surface. The first composite with 20% date palm rachis waste, and optimized, of course, is we can see the biomass is well distributed in the PLA matrix, and least voids are observed. For the second composite, actually the biomass is well distributed, but we notice that more voids are there. For the third composite, the biomass is well distributed and least voids are observed. So we can go to up to 27% from the biomass in the optimized formulas. We also tested the thermogravimetric analysis for the three optimized samples, and all the formulas showed good thermal stability up to, we can see, up to 95%. And they are all far from the processing temperature of 180, so the degradation temperature is much way far from the processing temperature. So the product is safe. Moving to the mechanical testing and starting with the tensile strength, and as we can see before this, the three prepared composites show like shiny surface, smooth and good after optimization, as we can see from the dog bone itself. And here from the tensile strength, we can conclude that the additives actually can enhance the ductility, the flexibility, processability of the composite, but this will reduce little bit the tensile testing. And we can see that the food grade petroleum-based plastics such as polyethylene, polystyrene, polypropylene, the one we used actually in our water bottles and our plastics, like they have a tensile strength varied from 25 to 69 megapascal, which is acceptable, and we are following, lie on the range. Moving to the Young modulus of elasticity, and the samples with low Young modulus actually are less stiff and more ductile and flexible, and all samples actually show acceptable elasticity. And ending with the elongation at break, and as we can see, the resultant elongation at break for the three formulas are acceptable since they are lying between 1 to 2.5%, similar to the polystyrene. I would like to conclude my presentation that we made these cutleries, and I am proud to say actually that Palm made a company in Dubai actually produce a biodegradable line and start the commercialization based on this novel work. So here the additives actually help to enhance the processability, the flowability, the durability, and enhance also the texture and the surface of the biodegradable cutleries, and enhance them. And we are ready actually with this formula in the market, and we have acceptable tensile strength, acceptable elasticity, and we will help to have a new economy in UAE and beyond. Thank you very much. Thank you. Any questions?
Thank you very much, Noran. So are there questions? Quite an interesting thing, and very close to the market already.
Yes.
Any questions? Yes, yes, please. One moment.
So much. Thank you for this great presentation.
Thank you.
My question, first one, can we use the same process to using this kind of fibers or this kind of biomass by using other polymers, semi-crystalline polymers like polypropylene, polyethylene, and others,
Yes,
and
yes.
get the same result?
We can. Actually, we have some testing to compare like like mechanical strength, the texture, and this, and we can go with this. But our aim is to reach like 100% biodegradable composite.
And from your experience, what is the maximum level you can put in the polymer from this kind of biomass?
For cutlery application,
to keep the same characteristic or to keep the
Yes,
same
actually-
processability of the product?
for other application, we may go up to 80%, and
Okay.
we found that we try to do like toys and things. We can go with this, but for cutlery application, we need to avoid the brittleness. We need some ductility. So that's why it is better to go up to 27% or 30% is acceptable.
Okay. Final question.
Yes.
From your experience, do you have any idea of the final use of this kind of product? Any use in the market, for example?
Like
Cosmetic application, packaging, or medical application, or maybe durable product like laptop, mouse, keyboards, things like that? Do you have any idea?
I believe that we can go for all the products, just optimizing the composite and optimizing the additives, and we can go for any product. We
Thank
believe
you.
in our composite.
Really,
Thank
it's
you.
a great product.
Thank you very much. Thank you.
Yeah, thank you.
So, thank you very much. So we thank you for the presentation and wish you big success in the market
Thank
with the
you.
new products. Thank you very much. And also I have a certificate of application for you.
Thank you. Thank you. Can I take a picture
Very
with
good
you?
presentation.
Thank you.
Thank you.
Thank you very much. Okay. Thank you.
Thank you.
Yes, one question is here.
One more question.
One more question, please.
Okay. Then we do everything for $500.
Yes, this is Zaid Abdulhamid Al-Halibi, Department Chair of Chemical Engineering, King Faisal University. I've been working on polylactic acid for the last around 8 years and composites material. It's very interesting topics. However, I would like to ask one thing. How did you check the uniformity of the additives throughout the PLA?
Again,
How did you check the uniformity of incorporation of those additives into the PLA? Uniformity. How do you make sure that the distribution of the additive is very uniform?
Yeah.
How did you check
Our
that?
first testing for that is a scanning electron microscope. This is our to check deeply inside the composite by scanning electron microscope, and also we send it also to other companies out external to ensure it is food grade and safe, and do water testing and all this. And because of these additives, actually the water absorption reduced very high.
Okay, now my second question is that if the PLA itself can do the job, why would you add the additives? Why you are adding the additives if the PLA can do the job?
The PLA actually is a good polymer, but it is having a problem with it is brittle, and this is a big issue with the PLA, and the processability is also need to be enhanced. Also, we need to reduce the cost of the polylactic acid as well.
Wish you all the best, inshallah.
Thank you.
Assalamu alaikum.
Thank you.
Thank you very much.